Okay, great, Wojtek. I think we're ready for part two.
Cool. Awesome. All right. Okay, so I've been driving this point into you, and I'll continue doing it, that chemical industry is truly everywhere, and we are dependent on it in many ways that we may not expect. So, for example, here on this figure, you can see all the random things that are being used, produced by partially by chemical industry. And for example, things that we associate with positive change, such as renewable energy, wind turbines, or solar panels, actually at this moment are using components that were being produced with oil. So that's somewhat of a sad and tough realization that as we talk about electrification, for example, which is definitely a very important step, we do have to think hard about how we actually make our batteries in terms of the process and in terms of the resources that we use. For batteries, for example, lithium and mining are a classic problem, but we can look at other things such as fertilizers, I think that we absolutely need because there's no other way to feed of the planet at the moment. But it does come with a big energy cost. The Bosch-Haber process being used in ammonia creation is responsible for a big amount of CO2 being released to the atmosphere. And when it comes to chemical industry, another thing that it's good to know is that it really starts in the same place, which is oil. And it's being divided into the sort of category of primary chemicals and then specialty and secondary chemicals. And the reason for that is because turns out that there's only a few things that we make. We just make them on a gigantic scale when it comes to the primary ones. So they are the ones being responsible for 2/3 of total energy input, but there's actually so few of them that we can easily list that on the scale. So on this part, so we have light olefins, ethylene, propylene, BTEX usually goes together, benzene, toluene, xylene, ammonia, and methanol. And just this, which I just listed, is responsible for the 2/3 of total energy input because we need those things to make pretty much anything else. So you look at all these different products on the right of the slide, and without starting from the primary chemicals, we won't be able to get there. So it's certainly an interesting perspective in terms of the upstream and downstreams that the chemistry industry is sort of divided into. And, in this presentation, you're going to see a ton of arrows because, in a sense, chemistry is all about change, and change means that something changes. So there are arrows going left and forth. So I hope you're not going to get too tired of it. But what I just said before about being able to abstract and think in those sort of universal terms comes true because we can pretty much make a flowchart of any typical chemical process. And I already mentioned that we need a feedstock, and then we have some chemical reaction that will also take energy and water or some other solvent. And every time you think chemical reaction, you talk about yield. So we're going to have a thing that we like, but also we're going to have waste. And then the world is not so simple. So oftentimes, as you make different products, you end up with a mixtures of things. Oil, the fossil fuel, is a great example of it, where it's actually a bunch of different molecules stuck together, and we have to process them and separate them. So you go through separation. And every time you hear the word separation, I want you to think energy consumption, because purely from standpoint of thermodynamics, you cannot separate things without putting energy. And that often means that we have byproducts. The byproducts from separation can be sold, or perhaps they're just a liability. And then we want to have a product. And what's very important is that this product is being sold to the customer, because without a customer, we cannot make money on things. And each of the steps come with environmental considerations. So it's pretty much the same thing I showed you on the previous slide, just emphasizing a little more of the different environmental considerations that we have here in mind. So we may want to think about where we take our water and what happens with this water. Oftentimes, water that is after chemical processes. A good example, for example, is fracking in all industry, but pretty much anything else, you often end up with contaminants. So you may have contaminated water that is very salty or has a strange pH, and all of it has to be dealt with. We think a lot about CO2 emissions because every time I say energy, that means that we have to provide it into the system. And oftentimes it's either you heat something up, or even if you use electricity, that electricity oftentimes was produced with a source that released CO2 at some point. And then, yeah, we have all of this coming together, and here it's neatly listed. So I'm not going to dwell too much on it. As always, I leave the source in my slides. So pretty much anytime you guys like a figure, it'll be shared later. And if you go towards the links, you can learn a lot more about that. And since I already mentioned the environmental liabilities, another thing that is really good to know about the chemical industry is that it's one of the most regulated industry in the world. And that counts for good reasons because we do produce a lot of different things. But investors in the modern sort of world, especially in venture capital, are often used to things that you can disrupt or move quickly. Say Facebook started with the you move fast and break things kind of motto, and this definitely should not apply to the chemical industry because the consequences of moving fast and breaking things could be dire. Not that social media is a simple thing, but I assure you the consequences in chemical industries are even more serious. So we fortunately regulate things starting from the 60s and 70s. So from the Silent Spring era, we started seeing different acts that every company in the US must abide by, such as Cleaner Act, Clean Water Act, or more recent ones such as the Biomass Research and Development Act. So planning to learn and study if you want to be in this space, because the regulatory system can be also quite complex. So I listed the big sort of federal acts, but every state and local agency can have a slightly different requirement, and they will matter quite a lot because if you produce a lot of water waste, for example, you have to work with your local municipality to understand what contamination levels are acceptable. That's actually something that I've learned studying breweries, so a little tangential, but definitely related to fermentation. You may want to understand the municipality well as work with them to make sure that you're not in violation of any of those laws. So chemical plants are complicated, and one can say that they're just a bunch of pipes. Another way to look at things is the famous arrows. You'll see arrows everywhere. And this is pretty much the same thing, just shown differently. It's a diagram of a cracker plant, so you can see how complicated those things are. But really, what it all that boils down to is that we take some feedstock, and then we have a chemical reaction, and then we have a product. And I think that in order to be successful in this industry, you have to be able to operate in all those different levels. Obviously, no one has the expertise to do everything at the same time. But as you think about assembling team, or if you're an investor who wants to invest in this space, pay attention and make sure that a company actually understands all these different levels. That there is somebody comfortable with chemistry, chemical engineering, the business and supply chain side of things. And like I said, on the simplest level, we have feedstock, chemical reaction, and product. And the big distinctions that I'll be drawing in this presentation is the feedstock. We can start with fossil fuels, or we can have biomass. In chemical reaction, we can have chemical process or biological process. And in product, honestly, oftentimes we just want to still get the same thing, or we want to make it better, as we always should strive to. All right, so the chemical engineering principles turn out to remain quite similar when it comes to the feedstock. The chemical reactor pictured on the left and the bioreactor pictured on the right, on some level, are the same thing. It's a volume where we can mix, we can bring different reactants, we can control temperature, we can cool things, we can vent things, and this is not going to change. So there's definitely a lot one can learn from the already existing chemical industry. We talk about revolution, and it is revolution in certain ways, but in other ways, it is quite important that we remain indebted to everything the chemical industry already discovered. And you can hire a chemical engineer who's been working in oil industry, that they can have very useful things for you when it comes to installation of the plant, for example. So yeah, something to keep in mind. And as I said, if the products and engineering don't change, we can have another way to look at things. So instead of an oil refinery, what we want to have is a biorefinery, where again, we start with some simple stuff, the sugars that are grown in plants, and then we apply some basic processes to get our primary chemicals. So before, we would have those fractions of oil. In this case, we may have sugars and oil and fats. And then we're going to have bioprocesses, often enzymes, to get what we need. It can be chemical products, but even fuel. In terms of fuel, one needs to be careful. Oftentimes, fuel is these days being used because you can always burn things for heat, and you can say, well, I am making money this way. But obviously, we want to be careful that we are not producing more CO2 back to the atmosphere. So it can be a way to make money faster, but probably you want to, if you are serious about being more environmentally friendly, I would encourage going more the chemical products route. In terms of fuel, it has to come with some carbon capture or some way of recovering CO2 back to useful products, I think. And a quote that I've recently learned from Sean Hunt from Solugen is that the reaction is for show, but separation is for dough. So over time, as you start in academia, people come and say, I have some very nice way of going from a basic feedstock all the way to the product. But what you have to think about is all I told you before about, which is atom economy and waste. And if you end up with a lot of different things, then you end up with a very expensive separation, which can be complicated, especially if the things are in similar volumes or they're similar chemically. So every time you're actually willing to invest something or start a business, really do your due diligence and think about separation. And the other thing that Sean told me is the concept of time yield. So you are obviously thinking about yield and the atom economy, but the other thing is time, right? So if somebody says, I have a great reaction, but it's going to take me 60 days to accomplish a reasonable yield, that's a no-go. So you do want to think about the time in this equation. So as you can see, things get things are complicated quite quickly, but I think that's what makes it a pretty fun space.
David made a comment that the synthesis gas, you can see it in the chat. He posted it to everyone. David, you can actually mention it because I think it's site specific, right?
I'm trying to pull out the chat.
Essentially, the comment is that the synthesis gas does not have to come from biomass. Other sources of CO and H2 are available at scale.
Yeah, good comment. Thank you for that. Absolutely, yeah. The purpose of this talk is giving a broad overview. Like I said, there will be an exception from everything I talk about because it is, when it comes to actual surviving and doing business here, you want to be very specific to your particular niche. And yes, later I have some slides on how we can get hydrogen more environmentally friendly, and it's definitely a very exciting technology. And I think Opus 12 was already mentioned, and sure, we're going to have a call out to it because I do want to talk a little bit about technological strategies. So I mentioned the chemical reaction versus bioreaction. And if it's still not clear for some of the people in the audience, I have some explanation here. So in all of these cases, we're taking feedstock into a product. But there's a question of what's actually performing the chemical reaction. And traditionally, a lot of things have been done with an inorganic material. So some catalyst, something that oftentimes may be a little toxic or expensive if it's a rare metal. And oftentimes things were also going to higher energies. So the challenges that I listed here is energy toxicity of price, as oftentimes in order to conduct the classic chemical catalysis, you do have to operate at higher temperatures. So one way to change things is to use biosynthesis with living organisms. So in this case, we have a bioreactor, and every microorganism is a mini bioreactor by itself. And it lives and grows and wants to do things. So we can either take it as is, or we can genetically engineer this organism to produce things that we are interested in, say insulin. But the challenge always going to be separation and instability. It is a living, breathing organism. So everyone who's dealt with fermentation assured me that things can get messy and some batches just underperform, or some seemingly small changes can lead to completely different outputs. So there are challenges here as well. So some companies started looking into hybrid technologies where they grow living organisms, but then they take only what they need from them, which is the enzyme. And then they put this enzyme into a chemical reactor to get the product from the feedstock. And this perhaps can be a best of both worlds. I put it with a question mark because really everything is so reaction specific. And by no means am I saying that chemical catalysis is somehow worse than biochemistry, but it's definitely good to, compare things side by side. And for specific product, you may realize that, say, bio or inorganic catalyst can be better. And to use some examples of companies that specialize in certain spaces, Opus 12 is dealing with inorganic materials, and they're doing a lot of great work. We got P2 Science as well. They started with ozonolysis, so using ozone, and I think now they're also using other inorganic catalysts. In the biospace, we have Zymergen, Bolthread, Genomatica, but really many other. This is just an example of these companies. And then from what I know, definitely Sologen is really bullish on this concept of hybrid catalysis, so taking growing organisms and just taking the enzymes for them. I know Novozymes is also in this space, and I'm sure you guys can tell us about some other companies as well. All right, so let's look at the market a little more closely. What are some of the biggest clean chemical companies in the market? We have got Jinko, Zymergen, so some of the companies I already mentioned. And yeah, I could tell you a little bit about every single one of them. They will come back in the later presentation. I think what's interesting to just simply notice is the size of them. So we are going into hundreds of millions of dollars, while the incumbents that you'll see on the next slides are in tens of billions of dollars. So we're definitely in the smaller space, and this is, not revenue. This is the funding. So that's also good to keep in mind. One of the sort of changes that I've seen when it comes to that space is before more companies that I would list would be interested in the biofuel space. And right now, when it comes to energy, we only, I think, have LanzaTech that is still mainly interested in energy production, and Enerchem. Amyris have completely pivoted from biofuels. So definitely there is the movement away from classic biofuels going into a sort of more complicated, specialty chemicals world where you are using biosciences and genetic engineering to target specific, high value products. And as you'll see later in my presentation, the high value is key because you want to be able to sell your product for some decent amount of money and not always fight against commodity world. And I mentioned incumbents. So this is only the chemical revenues listed. The chemical industry is in some sense an offshoot of an oil industry. Oil industry is still a few factors, I think, I don't remember the exact number, but a few times larger than the chemical industry. Sorry, oil is larger than chemical, I bet. And in terms of incumbents, we got BASF. The Chinese Sinopec is growing faster, so probably in a few years is going to catch up to BASF. Dow used to be the biggest when it was merged with DuPont last year, but now the spinoff is complete and the agrosciences are being split separately, and we have two companies, Dow and DuPont. DuPont didn't make the lists fully. It's at, I believe, something like $22 billion of revenue. And another thing to keep in mind with this slide is that all these revenues have shrunk in the last 2 years. We see about 5% decrease, if I remember, 5 to 10% decrease per company. And a lot of it is simply economy and especially COVID. I'll talk about COVID at the end of this part. And it definitely took a big hit because, as I said, the big chemical industry is pretty much tied to economy. And in this year, economy has been doing quite poorly. So we have seen some decrease in the revenues for our incumbents as well. So what is the incumbents' view on clean chemicals? Well, as I already told you, the incumbents are petrochemical companies, and biology is not their primary competence. So instead, they often focus on process efficiency and inorganic catalysts, as well as small-scale partnerships. I definitely want to say that the incumbents are not stagnant. They are thinking about sustainability, partially just simply because of regulation, competition. I don't know if they want to do it or they have to do it, but there is definitely some movement there. The best way to learn what they do is look at one of the sustainability reports that each of those companies are publishing. And for example, I looked at the BASF one, and I've noticed that they claim absolute greenhouse gas emissions going down by 50%, while the volume of sales grew doubled. It grew by 100%. So that's definitely quite impressive that the industry is able to increase their efficiency such that while the sales are increasing, the absolute greenhouse emissions are going down. Although later I have found out that there is some sort of number fudging going into space, as sometimes what happens is that the big companies are spinning off the dirtiest part of their supply chain and they're just offsetting it into their suppliers or their partners so that their numbers are looking better. Another example of it would be DuPont spinning off Chemour, where they dumped all lawsuits coming from water pollution onto another company. So one unfortunately has to take the corporate sustainability reports with some grain of salt, because there is good work happening there, but you do have to read the footprint and see whether there's been some strange spin-off going on, trying to hide some of the externalities. And the clean chemical space, as I said, a lot of companies are interested in fermentation. So it's also good to know the incumbents in pharmaceuticals. I'm not talking as much about them because those companies are interested, as the name suggests, in pharma. So the skills are quite similar, and those big companies are definitely expert in fermentation, but they have not been, as far as I know, spending a lot of time thinking and learning about how to make chemicals, because that's really a completely different supply chain. And a lot that it boils down to is making those partnerships and kind of knowing how to operate in the scale. So the small companies, the clean chemical companies, can partner with incumbents in chemical space to start a new bioproduct, but it's less likely than, say, Genentech and Dow will partner with something to make a new bioplastics, for example. So definitely good to know about them, because a clean chemical company can go towards medical uses, and there have been startups that have been doing pretty well going more towards medical uses. But in this presentation, I won't talk much about that. All right, so another slide that is more for the future when you guys get this presentation in the offline version. You can see that there's more and more companies growing in the space, and CB Insights did a nice job dividing them into different categories. So we've got, for example, renewable chemicals, multi-product, material fabrics, biofuels, etc. Not having much to say about this slide other than it's a good use, and feel free to ask me questions in the break if you want to. And market activity. Again, even despite COVID, there's been stuff happening in the market. Shout out to 50 Years. You guys are listed for your investment in Sologen. Congratulations on that. And I think it's good to sort of look at the bottom and see the different types of activity that's been happening. So we have investment, acquisitions, pilot, and partnerships. I'll be emphasizing in my part 3 how important it is to partner in this space, because it's a lot about capital and being able to make something on a larger scale, but also about know-how. The big companies are really aware of how the supply chain works, and they know how to make things efficiently. So in pretty much any case, it is really important to think about partnerships. And in a sense, the incumbents are not even exactly competitors to the small companies if things are done well. We can talk about that, but that's again something that I got talking to Sean from Sologen, who was saying that it's not exactly always the competition. All right, so product examples. There's like no way I can list anything near the whole space of clean chemicals, but a few things that caught my eye in the last 3 years. So, for example, Elevens is working on a pretty big plant. We're talking about 180,000 megaton capacity in olefin metathesis. So it's definitely a big market, again, a multi-billion-dollar market of olefin metathesis. And the difference is that instead of regular fossil fuel feedstock, they're starting with plants. Genomatica, they're doing pretty well. They won the 2020 EPA Green Chemistry Award. And their biggest product is butanediol, if I remember. That's BDO, again, pretty big market. And Genomatica is also pretty bullish on computer and simulation discovery of enzymes. So what they're doing is they're investing in different ways of improving and enhancing genetic engineering for their specific goals. So a lot of it is about finding the right target, so a chemical that you can improve, but then you also have to find a strain that will get the job done. So I think Genomatica is doing pretty good work in this space. In terms of plastics, there's definitely nice movement and more effort towards recycling, but also simply making plastics from bio sources. So one example is back to the Brazilian company Braskem. They have this green polypropylene. They claim that it's no fossil fuels are being used in this cycle. And then another example of big company, for example, would be Eastman, when again they're using bio feedstock to make different kind of plastic materials. And those are the sort of more industrial facing things. We should obviously talk about consumer facing as well. Again, this is COVID here, so cleaning supplies have underwent a complete explosion, and everyone wants to get it more disinfectants. And in fact, there's a big shortage there. So a lot of companies have been doing a smart work on pivoting towards making more cleaning supplies. The other ways to be more consumer facing and again get this benefit of consumer willing to pay more is looking at things like cosmetics or clothing, for example. And I already mentioned the US market, but it's good to think internationally as well. Obviously, the US politics is currently not very great for sustainability, as we all know. In the European Union, however, there is a more limited supply of oil, and there's more regulatory pressure that, in my opinion, creates a more favorable environment for clean chemicals. Europe just doesn't have a lot of its own oil, so it's a little more aware of not being dependent on it as a feedstock. And as you can see, there is a pretty good correlation between GDP per capita and consumption of things such as plastics and nitrogen fertilizers. So we want to bring the rest of the world up to the standard of living in Western Europe and North America. And that means the big boom in consumption of plastics and nitrogen fertilizers. So it's always good to look past other markets and think how that consumer demand is going to be growing, and how, fortunately, there are places like European Union that puts a little more emphasis on doing things more cleanly. And speaking of concrete initiatives, there's, for example, some global compliance initiatives such as REACH and restriction of hazardous substances. There are online initiatives and research initiatives. And lastly, there is a circular economy initiative in plastics. So things are definitely a little more active there. But it's in this year it would be impossible to not talk about uncertainty and COVID. So in past years, I was making a little more stronger claims that U.S. is way too dependent on shale oil, and shale was just predicted to explode in the next few decades. But as we all know, this year is nothing, just anything but normal. And in fact, if you look at oil consumption and CO2 emissions, we see a dramatic change. So for the first time ever, you see this red line here. This is the drop in CO2 emissions, and this is because of COVID. And that's tied to oil demand that is actually predicted to drop in things like power and buildings. Unfortunately, it's predicted to grow in things like plastic, and we will talk about that. And here I just want to give a quick shout out to Carbon Tracker Initiative, something that I came across quite recently. They do a really good job talking about dependence on oil and plastics. They're making a somewhat controversial claim that, in fact, oil industry and petrochemical industry should not bet on plastics because there may be a much lower sort of demand growth that we anticipate because of externalities. Simply, plastics are quite toxic for our environment in different ways. And, who knows how things going to look. So last time I was giving this talk, I was a little more confident in terms of the addiction to oil and what's going to happen with plastics. But this year, I'm just going to say things are just crazy. So I think this is the last slide before the break. So just tackling COVID directly head on, naturally the biggest disruptor of 2020. There's been dramatic consumer changes, and in fact, quite common temporary plant shutdowns. I think Dow, for example, closed 10% of their capacity for 30 days, and this is huge to their bottom line. The supply chain and production was heavily affected. And that's somewhat interesting because what I've been told, and that's anywhere across any pretty much advanced industry, but even the simple ones, such as toilet paper. We all know about the toilet paper shortage. And the reason why it happened is because of extreme lean manufacturing optimization. The same thing you can see in chemical industry. things are so well optimized and processes are just meant to go across a certain speed in terms of yield, like product per time. But when you have to like slow things down or change things because say there's a spike in demand when it comes to disinfectants or packaging, there's a huge down drop in oil industry, which chemicals are supporting in a variety of ways, for example fracking, automotive, aerospace, you have to shift things, and that has been taking a big hit in terms of efficiency and how things are well run. So here you can see some of the top concerns that the big CEOs of chemical companies had when it comes to COVID. And yeah, global recession is second, which is not surprising because I already told you the chemical industry is very, very linked to just general consumer demand. And yeah, another break. So happy to answer more questions, or we can just stretch, reset, and meditate.